The cold winter skies above Asia once held a predictable rhythm. Nations tested new aircraft, unveiled upgrades, and subtly shifted the balance of power. But on one particular day, the ordinary shattered, replaced by an extraordinary spectacle that echoed far beyond the continent's borders. What unfolded was not merely a test flight, nor a standard aircraft unveiling. It was a calculated, bold demonstration of engineering ambition, one that challenged every assumption about the future of military aviation. China introduced a fighter that defied convention in every possible way, and it did so with an unprecedented display. This was not the debut of a single new jet, but two. They ascended together, their synchronized ascent, a potent visual declaration of confidence and strength. The larger of the pair, later identified as the J-36, stunned observers with its enormous size and a unique design that hinted at a new generation of aerial warfare. Even more intriguing, the choice of the launch date carried a symbolism that few could ignore. This wasn't just about technology, it was a national statement. It signified an intentional message, meticulously crafted and delivered to a global audience. The precision of the unveiling, flying in daylight over Chengdu, one of China's most important aerospace centers, underscored this deliberate approach. It was a clear signal that China was no longer content with incremental advancements, but was ready to showcase a leap forward. The world watched, fascinated and concerned, as the implications began to unfold. What deeper message did this twin debut convey to the world, and how might it reshape our understanding of future air power? The J-36 did not emerge from the shadows of a clandestine hangar, a typical approach for sensitive military prototypes. Its first public appearance was a deliberate statement, flying prominently in daylight over Chengdu, one of China's most important aerospace centers. This choice of venue and visibility amplified its message. From the moment it took to the air, analysts across the globe noted how profoundly unconventional its design appeared. Its massive wings blended smoothly into the fuselage, creating a seamless, tailless flying wing. This specific aerodynamic configuration is known for minimizing radar cross-section, but it also presents significant challenges for stability and control, typically requiring sophisticated fly-by-wire systems. The absence of traditional vertical stabilizers, those familiar tails that betray radar reflections, was a stark departure from nearly all modern fighter designs, including existing stealth aircraft like the F-22 and F-35. Instead, the J-36 relies on advanced computational fluid dynamics and thrust vectoring to maintain control, pushing the boundaries of aerodynamic engineering. 3 large engines powered the aircraft, an arrangement no modern stealth fighter has attempted. This immediately raised questions. Was it for brute force, redundancy, or to power something entirely new? Conventional wisdom in stealth design favors fewer engines to reduce heat signatures and complexity. China's choice suggests a different priority. Most curious of all, the cockpit featured side-by-side seating for 2 crew members, a configuration more often associated with strategic bombers or large surveillance platforms than with nimble fighter jets. This design choice implies a much broader mission set than air-to-air combat alone. These radical design elements hinted that China's engineers were not simply iterating on existing concepts. They were forging their own path, seeking dominance in the skies through a truly unique architectural approach, one that prioritized different aspects of combat effectiveness. This bespoke design suggests a tailored response to perceived vulnerabilities and a vision for integrated warfare. How might this departure from conventional fighter design redefine aerial combat and challenge established doctrines? The propulsion system of the J-36 is as unconventional as its airframe, diverging significantly from the twin-engine standard of contemporary stealth fighters. While most modern fighters rely on 1 or 2 engines, balancing power with efficiency and stealth requirements, the J-36 employs 3. This configuration delivers several distinct advantages, signaling a shift in priorities for China's air power doctrine. First, it provides immense raw thrust, allowing the aircraft to reach speeds estimated at around Mach 2.5. Such velocity can quickly close distances, prosecute time-sensitive targets, or escape immediate threats, offering a significant tactical advantage. This raw power also contributes to its supercruise capability, allowing it to sustain supersonic flight without engaging afterburners. This is not a mere luxury, it's a critical operational advantage. Supercruise conserves precious fuel, dramatically extending the aircraft's range and crucially reduces its heat signature, making it far harder to detect with infrared tracking systems. This dual benefit enhances both endurance and survivability. Second, the three-engine layout offers crucial redundancy. If one engine fails, the other two can keep the aircraft airborne, an important factor for long-range missions deep into contested territory where recovery options might be scarce. This redundancy increases mission reliability and pilot safety, particularly vital for an aircraft designed for extended penetration missions. Third, and perhaps most importantly in the context of future warfare, three engines generate an extraordinary amount of electrical power. In modern warfare, where advanced radar, sophisticated electronic warfare suites, active electronically scanned array, AESA, sensors, and potentially even directed energy weapons demand vast and continuous energy reserves, this surplus power is invaluable. It means the J-36 can operate these power-hungry advanced systems continuously without compromise, giving it a significant edge over aircraft that must ration their energy use. This robust power generation suggests a strategic intent beyond pure kinetic combat, enabling it to act as a powerful electronic warfare platform or a command node for complex networked operations. Reports suggest the J-36 can carry between 13 and 15 tons of fuel internally, more than many smaller fighters weigh fully loaded, further contributing to its astonishing combat radius. Estimates suggest it could operate up to 4,000 kilometers from its base and, under optimized conditions, extend its range to 6,000 kilometers. With such range, American bases as far away as Hawaii could theoretically be within striking distance, drastically altering strategic calculations. What new possibilities emerge when an aircraft possesses seemingly limitless onboard power and unprecedented operational reach? At first glance, what makes the J-36 truly remarkable is its sheer scale, and this scale directly translates into its formidable internal arsenal, a defining characteristic that sets it apart from existing stealth fighters. Measuring over 23 meters in length with a wingspan of nearly 19 meters, it dwarfs familiar fifth-generation fighters like the F-22 Raptor or the J-20. Its blended body design, where wings smoothly transition into the fuselage, allows for a massive internal volume. This internal space is not just for show, it is critical for carrying both weapons and an enormous fuel load. Crucially, the J-36 forgoes external stores. Unlike aircraft that must rely on external pylons, which notoriously compromise stealth and increase drag, the J-36 holds everything inside. This design means it can approach contested airspace with its low observability characteristics fully intact, regardless of whether it is lightly or heavily armed. This simple yet profound design choice increases its survivability and allows it to enter hostile airspace without advertising its presence. Its weapon bays are particularly notable. The central bay measures approximately 7.5 meters long, an astounding length for any fighter, let alone a stealth platform. To put that into perspective, this internal bay alone is longer than the entire fuselage of some fourth-generation fighters, such as the F-16. This unprecedented size allows for weapons that most other aircraft could not even carry on external pylons, fundamentally altering its strike potential. Inside this cavernous weapons bay, analysts expect the J-36 to carry a diverse range of armaments, from advanced long-range air-to-air missiles, crucial for air superiority, to supersonic anti-ship missiles designed to threaten naval groups. The ability to house such formidable weapons internally means the aircraft can strike high-value naval assets, including aircraft carriers and escort ships, while remaining exceptionally difficult to detect. This presents an entirely new challenge to adversaries who have traditionally relied on carrier groups for power projection and sea control. Smaller side bays provide additional space for short-range air-to-air missiles or advanced sensors, adding flexibility to the aircraft's mission profile. This internal carriage philosophy fundamentally redefines the stealth payload trade-off. How might this hidden, yet devastating firepower reshape maritime and aerial engagements in the future? Equally intriguing to its radical exterior and immense internal capacity is the J-36's cockpit arrangement. a feature that immediately distinguishes it from almost every other modern fighter. Placing two crew members side by side is highly unusual for a fighter jet, a configuration typically associated with larger multi-role bombers, maritime patrol aircraft, or specialized command and control platforms. This deliberate choice reveals a deeper strategic intent behind the J-36's design. By giving each pilot their own full display and comprehensive control systems, the J-36 opens up entirely new possibilities for mission execution and crew synergy. In this innovative setup, one pilot can focus primarily on the demanding task of flying the aircraft, managing its complex flight systems, and maintaining critical situational awareness of the immediate airspace. Meanwhile, the second crew member can dedicate their attention to managing the highly sophisticated sensors operating the powerful electronic warfare systems, coordinating with other networked assets, or meticulously deploying the diverse range of weapons. In high-stress scenarios involving coordinated drone attacks, sophisticated electronic suppression of enemy air defenses, or intricate target identification and tracking, this division of labor significantly reduces individual workload. This reduction in cognitive burden dramatically increases mission effectiveness and overall combat resilience. It strongly suggests that the J-36 is designed for much more than traditional air-to-air dogfights, where a single pilot handles all functions. Instead, it is conceived as a command platform, a central coordinator, and potentially the centerpiece of complex multi-domain operations involving unmanned aerial vehicles, UAVs, and a host of other networked assets. This human-machine teaming approach is at the forefront of modern military thinking. The second crew member could be managing a swarm of loyal wingman drones, directing their actions, or exploiting vulnerabilities detected by advanced sensors. This configuration also allows for longer missions, as crew fatigue can be managed more effectively with shared responsibilities. It's a fundamental shift from individual prowess to collaborative, networked dominance. How will this two-person crew paradigm reshape the dynamics of future aerial combat missions, and what new operational doctrines will emerge from it? The combination of advanced stealth, unprecedented operational range, and a massive internal payload grants the J-36 capabilities that profoundly blur the traditional lines between fighter, bomber, and command aircraft. It is a truly multi-role platform designed for versatility and adaptability. This means it can strike distant targets with precision, escort other aircraft across vast oceanic distances, act as a central network hub for integrated operations, or disrupt enemy communications with its potent electronic warfare suites. Its sheer versatility transforms it into a true force multiplier, capable of performing roles that previously required multiple different aircraft platforms, each with its own specific limitations. This adaptability is precisely what makes the J-36 particularly challenging for adversaries. Military planners can no longer simply categorize it. They must now account for a single platform that can appear in a multitude of different operational contexts, each time presenting a unique and formidable kind of threat. As the aircraft's features became clearer, comparisons with American fighters were inevitable and often unfavorable to existing Western platforms. The F-22 Raptor, long considered the undisputed gold standard of air superiority, suddenly appears more limited in range and internal payload compared to the J-36. With only two engines and smaller weapons bays, its endurance and armament capacity are inherently constrained. The F-35 Lightning II, designed for versatility across multiple services, still cannot match the sheer endurance or internal volume of China's new design. Its single engine restricts both its power generation capacity and its redundancy. The J-36, by contrast, can project power across entire oceanic theaters, a capability traditionally reserved for strategic bombers. Some analysts have even compared it to strategic bombers in terms of reach, while still retaining fighter-like agility, a combination that has been elusive until now. The United States has certainly recognized the immense challenge, responding with accelerated development of its next-generation air dominance (NGAD) program. Though details of NGAD remain highly classified, the implications for naval power are particularly profound. The J-36's ability to carry long-range anti-ship missiles internally means that carrier strike groups, traditionally symbols of American power projection and global reach, are now at greater, more immediate risk. These missiles can travel at supersonic speeds and cover distances that strain even advanced naval defenses. An aircraft able to launch such weapons while remaining largely invisible to radar fundamentally shifts the balance at sea, compelling naval strategists to fundamentally rethink deployment patterns, defensive postures, and even the future viability of aircraft carriers in high-threat environments. What strategies will nations employ to counter a platform of such multifaceted capability that disrupts long-held military doctrines? Beyond its direct military tactics, the J-36 carries significant economic and diplomatic consequences that will ripple across the globe, fundamentally altering strategic landscapes. Developing such an aircraft demonstrates unequivocally that China's industrial base is not only capable of producing world-class aerospace systems, but has matured to a level where it can innovate on a scale rivaling any other nation. If production proves efficient, China could field the J-36 in numbers that could potentially overwhelm adversaries through sheer quantity, a critical factor in any sustained conflict. This capacity to mass-produce advanced platforms signals a formidable industrial might. Economically, this forces other nations to respond with increased defense spending, often redirecting precious national resources from other critical domestic priorities like education, healthcare, or infrastructure. The financial strain of keeping pace with such rapid technological advancement will be immense, potentially leading to difficult choices for national budgets worldwide. Diplomatically, the aircraft significantly strengthens China's hand in international relations. Advanced military technology frequently translates into greater influence in negotiations, strategic partnerships, and geopolitical maneuvering. Nations seeking to counterbalance regional threats or enhance their own defense capabilities might look to China as a potential partner or supplier, even if indirectly. Allies and competitors alike must now fundamentally reassess their assumptions about China's technological maturity, its capabilities, and its long-term strategic goals. The J-36 is more than a weapon. It is an instrument of national power projection, a symbol of a rising technological superpower. Its existence reshapes perceptions of China's military might and its capacity to challenge established global orders. This technological leap also impacts arms control discussions and regional stability, as nations try to understand the new balance of power and its implications for conflict deterrence. The sheer cost of developing and fielding comparable systems will stretch the budgets of even the wealthiest nations, creating an asymmetry in military investment. How will this technological leap reshape global alliances and rivalries in the coming decade, and what economic sacrifices will nations be forced to make? The emergence of the J-36 necessitates a profound and rapid evolution in both operational doctrine and pilot training, challenging long-standing traditions in air forces worldwide. Pilots traditionally trained on single-crew fighters, where they personally manage every aspect of the mission from flying to target acquisition, will have to adapt to the complex demands of sharing tasks in a side-by-side arrangement. This is not merely a matter of familiarity, but a fundamental shift in combat philosophy. New tactics will inevitably emerge, with one pilot perhaps specializing in the intricate aspects of drone coordination, electronic warfare, and data fusion from multiple sensors, while the other handles precise navigation, flight control, and core kinetic combat maneuvers. This division of labor allows for a much higher cognitive load to be managed effectively, enabling more complex and coordinated operations. Ground crews, too, will need to master the intricate maintenance of the complex three-engine system, balancing the inherent benefits of redundancy with the higher servicing demands of an additional engine and its associated systems. The blend of conventional and unconventional components, advanced stealth coatings, and sophisticated internal systems will require new training protocols and specialized expertise. Doctrine writers face the formidable challenge of integrating this highly versatile platform into broader military structures. Will it serve primarily as a long-range strike aircraft capable of deep penetrations into enemy airspace? Will its primary role be a command hub for networked operations, orchestrating swarms of unmanned assets and coordinating with ground and naval forces? or will it function as an air superiority fighter capable of challenging and defeating the most advanced enemy aircraft? The truth is likely all of the above, depending on mission requirements, demanding unprecedented flexibility in its deployment and a fluid understanding of its multi-role capabilities. This adaptability means that mission planning will become significantly more complex, requiring sophisticated simulation and advanced decision-making tools. The training pipelines will need to be completely overhauled, from initial pilot selection to advanced mission rehearsal, preparing crews not just for flying, but for systems management and networked combat. How quickly can existing military structures adapt their training and doctrine to effectively leverage such a revolutionary platform? And what are the risks if they fail to do so? The J-36 also highlights the increasingly critical role of electronic warfare, EW, in modern conflict, and its undeniable fit into China's broader military modernization strategy. In contemporary conflicts, disabling an adversary's sensors and communications can be far more decisive and often less destructive than simply shooting down their aircraft. It's a battle for information dominance before the kinetic fight even begins. With its immense onboard power generation from 3 engines, the J-36 can likely run electronic warfare suites far more advanced and sustained than anything previously deployed by China. These systems could jam enemy radar with overwhelming power, blind incoming missiles with sophisticated countermeasures, or even disrupt satellite communications, effectively isolating parts of the battlefield. Such capabilities transform the aircraft into more than just a kinetic strike platform. It becomes a weapon of information dominance, capable of shaping the battlefield and neutralizing threats before a single missile is launched, providing a significant first strike advantage. Furthermore, with its large internal bays, powerful array of sensors and 2-person crew, the J-36 is ideally positioned to act as a command platform for swarms of drones. In this vision of future combat, the J-36 would not necessarily need to engage in every dogfight itself. Instead, it could launch, direct, and coordinate dozens of unmanned aircraft, overwhelming opponents through sheer numbers, distributed sensors, and the complexity of their coordinated actions. This transforms the fighter from a single combat unit into the centerpiece of an aerial ecosystem, one that multiplies its effectiveness far beyond its own physical capabilities. This concept, often termed loyal wingman or drone mothership, leverages the strengths of both manned and unmanned systems. The manned J-36 provides the strategic decision-making, high-level command and control, and complex sensor fusion, while the drones perform reconnaissance, electronic attack, missile saturation, or even serve as expendable decoys. This synergy creates a formidable challenge for any air defense system. It's a vision where the J-36 becomes the brain, orchestrating a complex ballet of destruction and deception. How might the J-36's electronic and unmanned warfare capabilities fundamentally alter the very nature of future conflicts and decision-making on the battlefield? The psychological effect of unveiling such a revolutionary design should not be underestimated. For decades, adversaries often viewed China's military technology as largely derivative, limited to copying older designs with varying degrees of success. Now they must confront compelling evidence of true innovation and independent technological advancement. The message is clear: China is willing to take significant risks, invest vast national resources, and experiment with designs previously thought too complex, too expensive, or too impractical for others. This dramatically alters how nations calculate risk in any potential conflict involving China. The simple knowledge that the J-36 exists, that a platform with these capabilities is being developed and potentially fielded, forces militaries around the world to prepare for scenarios that were previously theoretical or considered far-off possibilities. This shifts planning from an assumed technological parity to an acknowledgement of a potential immediate threat. Deterrence works not only through demonstrated physical capabilities, but also, crucially, through the perception of those capabilities by potential adversaries. And in this regard, the J-36 has already achieved a significant strategic victory. Its mere existence acts as a psychological deterrent, complicating strategic assessments and compelling other nations to reconsider their own defense postures. However, when analyzing its future, one must also consider the harsh realities of advanced military aircraft production. Stealth aircraft are notoriously difficult and expensive to manufacture, requiring precision tolerances, advanced composite materials, and sophisticated manufacturing processes. If China can master the mass production of the J-36, consistently delivering high-quality operational aircraft in significant numbers, it will signal an industrial maturity equal to or surpassing any competitor. This would be a profound testament to its engineering and manufacturing prowess. But if the design proves too complex, too costly, or too difficult to sustain at scale, the number of operational J-36s may remain limited, significantly reducing its strategic impact and long-term threat perception. The true test will come not from prototypes or initial flight demonstrations, but from whether squadrons of operational J-36 appear in the coming decade, integrated into exercises and deployed to forward bases. Should that occur, regional power balances would undoubtedly shift dramatically, and long-standing assumptions about air dominance could be irrevocably overturned. What factors will ultimately determine the success of this ambitious project? Will it be technological brilliance or the pragmatic realities of mass production? The global defense industry is already reacting swiftly to the J-36's unveiling, and these ripple effects are poised to reshape military technological development for decades. Western defense companies are increasing investments in next-generation radars, designed specifically to detect low observable aircraft, alongside advancements in hypersonic weapons that can challenge advanced defenses and autonomous drone programs that aim to counter or complement the J-36's capabilities. Nations are reassessing how to allocate their limited defense resources, with some diverting funds from legacy aircraft upgrades into future-focused projects, accelerating procurement cycles for next-generation systems. This competitive environment may ultimately accelerate technological progress worldwide, leading to new breakthroughs that ripple across both military and civilian aerospace sectors, from materials science to artificial intelligence. In this way, the J-36's influence extends far beyond China's borders, fundamentally reshaping how the world views the future of aviation and warfare itself. If China ever considers an export version of the J-36, the impact on global arms markets would be enormous. While Beijing has historically been selective about which nations receive its most advanced technologies, even a downgraded version could drastically alter regional power balances. Nations that cannot acquire American or European cutting-edge fighters might look to China as a supplier of advanced stealth aircraft, disrupting traditional arms trade relationships. Such exports would not only bring in significant revenue for China, but also expand its sphere of military influence, creating dependencies that tie foreign air forces more closely to Chinese technology, training, and doctrine. This would solidify China's position as a major player in the global defense market. For Europe, the emergence of the J-36 places immense pressure on collaborative programs like the Global Combat Air Programme, GCAP, being developed by the United Kingdom, Italy, and Japan, and France, Germany, Spain's Future Combat Air System, FCAS. Timelines that once stretched decades into the future may need to be drastically shortened, lest the technological gap widen further, making their future fighters obsolete before they even fly. Governments will be pressed to commit greater funding to ensure their sixth-generation projects remain competitive and relevant. This means defense budgets across Europe are likely to rise significantly, diverting resources from other sectors and potentially straining national economies. The J-36 has, without a doubt, become a catalyst for a worldwide acceleration in fighter development, fundamentally reshaping economic priorities as well as strategic ones. It has ignited a new era of military competition, compelling every major power to innovate faster, spend more, and rethink their entire defense strategy. The future of global air power has irrevocably changed. The unveiling of the J-36 on that symbolically chosen December day was more than a display of raw technological prowess. It was a clear, deliberate message to the world that the landscape of global military aviation has been irrevocably altered. We stand at the precipice of a new era, one where long-held assumptions about air superiority, power projection, and strategic balance are being challenged and redefined. The J-36, with its radical design, immense range, and multifaceted capabilities, represents a philosophy of air power that prioritizes stealth, payload, and networked versatility over traditional maneuverability. It suggests that the future of aerial warfare will be decided not by short-range dogfights but by long-range strikes, sophisticated electronic dominance, and seamlessly integrated networks of manned and unmanned systems. This shift impacts not just the pilots in the cockpit or the engineers on the drawing board, but entire national defense strategies, economic priorities, and diplomatic relations. The ripple effects are already being felt, accelerating research and development in counter-stealth technologies, advanced missile defenses, and rival next-generation fighter programs across the globe. We are witnessing the unfolding of a new arms race, driven by innovation and the relentless pursuit of an advantage. The psychological impact alone is profound, forcing nations to confront the reality of China's independent technological maturity and its willingness to push boundaries. As we look ahead, the questions multiply. Can other nations truly keep pace? What unexpected breakthroughs will emerge from this intensified competition? And ultimately, what does this new philosophy of air power mean for global stability and the prevention of future conflicts? The J-36 is not simply another fighter, it is the vanguard of a new generation of warfare, prompting us all to consider what tomorrow's skies will look like and who will command them. The implications for peace and conflict are immense, demanding thoughtful consideration and a clear understanding of this evolving technological frontier.